Hello there, Mr. Sutton here, bringing you the IM3 Honors 1-2 Extra Practice Number 1 solutions on operations and compositions of functions. On this problem, we want to do g plus h of x given these two g and h functions. So basically, we have to take g of x plus h of x. Well, g of x is just 4x plus 3, so we're going to be adding that to 3x cubed minus 2. That's h of x we're adding in there. And the rest of this is basically just combining like terms. So just writing these things from greatest to smallest exponent, we've got 3x cubed, and then, let's see here, there's only one x term, this 4x, we'll just rewrite that, plus 4x. And then we have a positive 3 and a minus 2 combining to positive 1. For this problem, we're doing g minus f of x, given the g and f functions here. So this is saying we want to do g of x minus f of x. So negative 2x cubed plus x squared, that's g of x, minus all this f of x stuff, x plus 2. Notice I'm using parentheses. I definitely need it on the second set of things. The first set I didn't really need it on because there's nothing that comes before it to multiply by it, but we'll have it there anyway. All right, so now I'm going to just drop that first parentheses because at this point I'm just simplifying, combining like terms. The second parentheses, I have to distribute a negative 1 to both of those. So this is going to be negative x minus 2. Combining like terms, we've actually got no like terms to combine. We have third, second, first power, and a constant. So that's actually as good as it's going to get. For this problem, we're doing f times g of t for the f and g functions given here. So we're basically doing this whole f of t function, 2t cubed plus 5, all of that, which I'm going to put in a parentheses, times the whole g of t function, so times parentheses 3t plus 1. And all there is to do at this point is simplify, so FOIL this out, combine like terms, whatever else we need to do. So we have 2t cubed times 3t, that's going to be 6t to the 4th, and then the outers is going to give us 2t cubed. Inners, that's 5 times 3t is 15t, and the lasts, 5 times 1 gives us plus 5. And if we look here to combine like terms, there's actually nothing to combine, and as it happens, we're also going in decreasing order of exponents, so even better, we're done. For this problem, we're doing f over g of a, so basically f of a divided by g of a. Well, here's f of a, negative 2a squared minus 3a. And we're going to divide all of that by g of a, which is just 2a minus 4. So at this point, we'd look to see if we could combine, maybe take out common factors and cancel them. But if you look at this, there's really nothing to factor out here. So this problem is as good as it's going to get. For this one, we're doing g plus f of negative 2. So this is essentially saying g of negative 2 plus f of negative 2. G of negative 2 is going to be this g function with negative 2 plugged in for a, so negative 2 minus 3. F of negative 2 is going to be negative 2 squared plus 5, so we're going to add all that, and I'll put it in the brackets here so I don't lose anything. Simplifying a little bit, in this first bracket, negative 2 minus 3 is going to be negative 5, and over in this other bracket, negative 2 squared is 4, plus 5 gives us 9, so we have negative 5 plus 9, which all adds up to positive 4. On this one, we're doing h minus g of negative 7, given the h and g functions up here. So we're doing h of negative 7 minus g of negative 7. H of negative 7 is going to be 2 times negative 7 minus 4. G of negative 7, that's going to be 2 times negative 7 minus 2, and I'll subtract all of that in its own bracket over here. So we're doing, again, h of negative 7 minus g of negative 7. That's where this is coming from. Now to simplify a bit, we've got over here negative 14 minus 4, and we're subtracting over here, we've got negative 14 minus 2. So that's going to be negative 18. And we're subtracting negative 16, so plus 16 then. All of this then is going to add up to negative 2. For this problem, I'm doing f times g of negative 3. So that's f of negative 3 times g of negative 3. F of negative 3 just by itself would be negative 3 plus 5. So I'll put that in a parentheses, and I'm going to multiply that now by g of negative 3. G of negative 3 is negative 3 cubed plus 5. And although it comes out to the same thing either way with odd exponents, I'm going to put my negative 3 in a parentheses there just for correctness, completeness sake. Now it's time to simplify a little bit. So for my first step, all I'm going to do actually is just do a negative 3 cubed, which gives me negative 27. And now I'll simplify a little bit more on each of these. This first bracket, negative 3 plus 5 is 2. Over here, negative 27 plus 5 is negative 22. And then 2 times negative 22 gives me negative 44. On this one, I'm doing g divided by h of 8. So essentially, I'm doing g of 8 divided by h of 8. G of 8 is going to be 4 times 8 plus 2. H of 8, that's going to be negative 2 8 squared plus 3 times 8. And now I have to simplify this. In the numerator, this is going to be 32 plus 2. In the denominator, we've got, let's see here, 8 squared is 64 times negative 2 is negative 128. And then 3 times 8 is 24. I'll be adding that. Going a little bit further here, 32 plus 2 is 34. Negative 128 plus 24 is negative 104. So I have 34 over negative 104. And I think I can simplify this a little bit more. These are both divisible by 2. That would give me 17 over negative 52. And I don't believe we can go any further. 17 is a prime number, so that's as good as it's going to get.